Hello, everybody. My name is Rincover. I'm a principal designer in Nokia's location and commerce unit, working at our Berlin site. Just want to emphasize that all the work you're seeing is actually done right here in Berlin. And within the location and commerce, we're combining Nokia's strength in location-based services with map making from Navtech, a company that Nokia purchased several years ago. And so, even though the location and commerce unit was only set up last summer, together we have about 20 years of experience in the art and science of maps and location under our belt. So today I have the pleasure to talk to you about the evolution and future of maps. But first I want to take you on a little tour of how we abstract the world. So, some of you have probably seen this before. This is the mixed reality spectrum. So on one side we have 2D abstractions. On the other side we have AR, which is augmented reality, and everything in between. The 2D is basically this synthetic version of our reality, whereas the augmented reality is our reality with the digital on top. So what's interesting about this spectrum is that it loosely follows the way that maps have developed over time. And what I want to share with you today is an idea that this mixed reality spectrum is actually, from this flat line, is actually curving into a circle, and we're creating an entirely new one-world spectrum. So we've been at this for a long time, that is, people in general. We've been organizing ourselves into towns, planting crops, making maps to help us understand the world around us. And this is a clay tablet, discovered in South Iraq from the 6th century BC. We found maps as far as 14,000 years ago. With exploration of the world, our understanding of the world grew, and therefore so did the complexity of maps. You see this highly detailed map, but it's still essentially the same as cave drawings. It's paintings, etchings, and all this, and it's abstractly describing our three-dimensional world in 2 dimensions. So, then with the age of computers and the internet, maps have undergone a huge pivotal change, relying on a limited set of statistical information to then becoming these flexible, dynamic, data-driven view of our world. So with greater technology came better quality, accuracy, and we can start to see the real world as photographs. Or we can abstract the world with terrain information, start to show what the world is looking like. Then with all this mapping happening, you see multiple use cases out there. You see, this is our plan a next trip, but you guys have seen weather, you've seen all kinds of public transportation, and you name it. Everything is then possible as a use case in a flat map. Then we can take this flat map, we can rotate it, and build 3D landmarks to help you have a rich navigational experience over the map. So here you're able to see where main elements are, and then from there you create this extra dimension into this globe. But for all the advantages of the map, these are essentially the same thing. The 2D representation is not that much different from our ancestors. So what I'm here to share with you is what I believe is next. And to tell you, maps are changing dramatically. The future right now is photorealistic apps, and all of this stuff is happening in the browser without plugins, without complex technology for a user. So there's no more downloading and installing and doing all this. Basically, WebGL and the new technologies allow users to directly work in multiple dimensions on the map. So here's where we take this mixed reality spectrum and start to curve it and create a one-world concept. So we can take all 5 different types of experiences and create one kind of seamless experience where there are seams and we try and make them seamless. But the closer to reality, the greater the complexity, and the technology and data required changes. But we don't want to put that onto the user. The user should have as simple of an experience as possible. So one of the largest steps is going to a 3D world. So what we now have here is a fully automated mapping process, where this is actually taken from airplanes that are flying over the city and taking millions of photos and algorithmically developing three-dimensional maps. So in this one, we're going from the Fernsehturm to where we are here today. So this is taking, this version is with airplanes and is all above a certain level. But with 3D, you're not limited from seeing from one perspective or this mile-high angle. You can get a better sense of the place by flying around. And so we give you superpowers to be able to fly around a city. 3D is this huge leap, but still one step away from our reality. And reality is often on the ground and at street level. The first-person perspective is another type of abstraction. And so what I want to take you into a little bit is how we collect some of this data. And what we're doing is we're developing these systems for automatically generating these interesting 3D worlds that are partially photoreal, partially abstract, and there's a mix done by various methods of collecting data along the streets. So using vehicles with super high precision sensors, they are collecting millions of 3D points every second. And they're taking this using lasers and abstracting a 3D data cloud from the cars that are driving. And we have lots of cars driving different cities all over the world. As the lasers map the 3D world, the GPS on the vehicle records the car's location all the time, continuously. And every single point is then geolocated in space. So we're able to create these three-dimensional environments just from driving around. It's automatically generated. There's no hand modeling any of this anymore. And as they're driving around, this 360-degree view is being generated everywhere the vehicles go. And they're creating what's called bubbles. So there's actually these separate bubbles, and all the bubbles can then tie together. So every bubble you're seeing is a little piece of the world. So in this one, I want to point out, watch the cars disappear. We're now developing the 3D world as it's driving. This is a sample of the points that are being collected while the vehicles are driving around. So about these seams. So with the airplanes flying by and the cars on the road, we now have a seam between the two different types of data we collect. So we're working on different ways of blending the data from one type of capture to another type of capture. So you can travel from space to space and essentially make the transition seamless. We can then make uniquely identifiable buildings and capturing separate buildings so you can see what is inside the buildings and know that this shop is in this location. So these map features can be extended along the street. Street vector data allows drawing paths and interesting things within this world. So these bubbles you were seeing earlier, we can then take all these still images and generate all kinds of transitions between bubbles. So you can see here, this video-looking fly-through is actually generated from still images moving along the street. So. And then the third area is this augmented reality and the way that it then puts ourselves well, we no longer have to put ourselves on the map. The map is then wrapped around us. So it's this inverted type of map. And this is a pretty amazing shift that's happening right now. With exploring, the AR helps to support our decision making at a glance. So if you're moving down the street and you just hold up your device and you scan the street, you can see quickly what's happening. Information sent of the types of places positioned around you. You can tell if this area is good for shopping, or display more search results naturally and filter them naturally by whichever direction you're looking. So you don't have to always type in, I'm looking for coffee, I'm looking for this. You can just take your device and move it around in space. So we can use real-life cues to support the decision-making process. So a little bit of the details on how complex this topic is we want to know how can we leverage all the assets we collected throughout this evolution to improve this experience. There are technical challenges of registering all this data. You have vehicles, you have satellites, you have airplanes, and when you're capturing from different points of view, there are quite a lot of mismatches, and you have to understand where these different pieces fit together. So we can use various technologies to provide better alignment between these different worlds to help provide a better experience and improve our tracking and enhance things from a user's point of view, because we're continuously looking at from where the user is. So you can see here we can then use transparency to offer depth. So different items become farther and closer, and we can use these building models to show that some things are not in view because they're behind the building. So occlusion models. And then, of course, you can make everything touchable and clickable. So your device moves around freely, and you can select things and get enhanced information about this place. So then I want to show you a few live demos. So in a moment, I'll show you the welcome to mapsnokia.com. That's where we are at the moment. And what I wanted to show you guys is mapsnokia.com/webgl. So this is currently on our live site, and you can travel around the world. It's a full 3D rendered environment. So this is completely captured by airplanes flying by. There's almost no handwork involved in this anymore. So there's none of this 2D flat world with handmade landmarks on there. This is a completely 3D environment. And what I want you to notice is that this is a very large section of high-resolution 3D. So if you see where the dark areas are, this is normal satellite imagery. And this entire area all the way down here and beyond now is captured in 3D. So you're probably asking, like, what can you do with this? So we can go go back to San Francisco. So you can do regular searches. And we show you, without occlusion, where things are. You can see that the flags are in the 3D world. And you can do coffee anywhere. So without having to retype a search, we do it in the least amount of effort here. So I want to search for coffee anywhere. Doesn't matter. There's coffee. Coffee. Simple. You can change it to tea, whatever we like. So I also want you to notice that there's a nice little button up here. And this is the part where you put on the glasses. Yeah. How's it looking? One of my favorite buildings, the Empire State Building. So with the 3D, we're developing APIs for developers and for people to be able to take advantage of this world. You notice the name of the cities. Now things are starting to show up in 3 dimensions. We don't have to fix everything in 2D in a flat world anymore. Labels, everything is now going to be 3D. So I'd like to show you another example of what can be done with the API. This is an example page, so it's not live, but it's a special demo for today. So this is another version of our WebGL. This is using our API. It's not released yet, but we're working on that. It works very similar, but it has some extra features. So this is not 3D anymore. Okay, this version has some features in here. Let's say you want to take a use case like, I want to go out, I want to have a date tonight, and I just want to see a few things. So what I can do is, I'm in San Francisco, and I can say, I want to go to the theater. Okay? And it shows me just the places around San Francisco. I say, okay, I want to go to this theater. I'm not interested in 5 different theaters, I just want that one theater. Right? Okay, but now I want some dinner or something else. So now we can go here and we can say, okay, I want to grab some dinner nearby. So here's dinner, and then I want to go to a club. And what you're seeing is the automatic routing and all the places that I want to go as an itinerary done in 3 steps or so. You don't have to do 3 different searches. You don't have to do a lot of work. Take some of the basic things that you'd be interested in. It makes it very quick. Now, so I have something I think is very, very special to show you today. So I just show it. I'm not going to talk about it. This is what you can do with WebGL. So this is actually a live web page in three-dimensional space over the environment. And it's a live page. I can scroll it. Let's pick out something fun. I always like going to the Golden Gate. So Golden Gate with the web page above the Golden Gate. And this and then we'll go back. Then I can do a search, Transamerica. Yeah, Transamerica Pyramid, one of my favorite buildings in San Francisco. And as you can see, the three-dimensional map and the image from Wikipedia overlaid. There are no more flat worlds. There's only this multi-dimensional world, what I'm calling the one-world map. You can see everything's in the world. So basically, every wiki page that you can imagine is distributed around the globe. And you can go from page to page. And then if you close these pages, you're left with a little piece of where you've been. So there's your history. And you can see the other one in the back. If we rotate around, oh, there it is. There's the Golden Gate page. So that's about what I have for you today. I'll leave you with the 3D. If I can find my... If anybody's interested in the Sing Another City, there's quite a few around the world. We have 25 cities. I particularly like Cape Town in 3D. So if you have the 3D glasses, I think it's quite nice to go over to tabletop. Check out the view. Thank you very much. Yeah.